Now let's talk about data authentication. Data authentication. So remember, one of the mission of data security, one of the mission of a network security is to ensure that data has not been modified. So that means it needs data integrity. So data integrity can be ensured using data authentication. So let's assume that Alice has a data M, and so there are two things we want to make sure. The first thing we want to make sure is that M has indeed come from Alice, right? So let's say sends to Bob. The second we want to make sure is that M has not been modified during transmission. So we can, if both Alice and Bob share, if Alice and Bob share a secret key, okay, then encryption will serve both purpose using K. Then encrypted M will serve both purpose. Right, so this message has been encrypted using the shared secret key K. So when Bob decrypts it using this K shared with Alice, if it is successful, that means that Alice encrypted this message M. So that proves that this message indeed comes from Alice. And the second thing that Bob will know is that M has not been modified. So in order to ensure that M has not been modified, so it needs Alice to send the original message as well. Okay, so Bob decrypts this ciphertext, gets M, and compare that M with the M in plain text that Bob gets from Alice. If they are equal, that means that M during transmission has not been modified, okay, because this has been encrypted. So, but of course, Alice may not want M to be seen. So then how can we obtain data integrity if Alice doesn't want to reveal M? So there is a method. So instead of sending over M, Alice can use a strong cryptographic hash function to hash M. Right, so instead she can, so this is encrypted, and then attach H of M. Now this is a hash, so from here it's impossible to get M. So then send this over, so Bob then can decrypt this, get M, and then compute H of M, and then compare. So So that is a methodology using share secret key K. If Alice and Bob don't share a secret, for instance, Alice just want to say, this document comes from me, and regardless who the recipient will be. So then Alice can create, so the other one is using PKC. So Alice creates let's say we use RSA, right? And Alice generates a parameter en, so this is public, so anybody can have it. And then dn, this is private. Only Alice knows this. So for this message m, let's assume that m is less than n, then she can just simply sign it. So she signs it by doing m to the d my n. Anyone, okay, can decrypt this, right, with a message. So anyone can decrypt this and then compare whether this m, so when you decrypt this, you get the message m, and then compare this m to see whether that m is identical. That means Alice has signed this m. Again, there are two issues here. One is you don't want m to be in plain text if you don't want a non-relevant person to see it. Okay, just like the first case. The more important case here is that using public key to sign a message m on itself may be too costly, because if this m is too big, okay, and then it may be costly. So the way to do this authentication is to compute, again, using a strong cryptographic hash, to compute a hash, and then you sign it. So you sign on this hash function. So that is authentication, okay, to indicate this m indeed comes from Alice. So this is the signature. Okay, so this is the signature of m. Signature on m by Alice. All right. So that's two ways to do data encryption. And of course, we can combine these two methods to come up with a scheme, depending on which data encryption algorithm you are going to use and which public key encryption you want to use. Then we can combine these two to come up with a stronger scheme. So data authentication ensures data integrity. Okay, so this is ensure data integrity. And the other thing here is that it also ensures data non-repudiation. Also, data if Alice has non-repudiation, if Alice has signed it and she cannot repudiate that she has ever signed it, because this scheme can reveal that she did indeed sign that message. Hence, data authentication is an important mechanism used widely in network security. Okay.